All right, so here's an example. So remember, mathematically, we're talking about u of x is the potential energy function. Okay, the derivative of that is the negative of the force. Okay, and when the slope equals 0, that means the particle is at equilibrium. Okay, that would be at equilibrium. Okay, and then when you take the second derivative and check the sign, right, stable, concave up, right, would be like in a valley. Right, that would be like in a valley. Okay, and then unstable, concave down would be like on a hill. Okay, good. All right. Okay, so here's what's going to happen is you have this potential energy for the particle is given by this function. The particle is not subject to any non-conservative forces, right, which means we can just do straight conservation of energy, no friction, no work, no nothing like that. And its mechanical energy, right, which was basically its potential plus kinetic, is constant at negative 0.25 joules. Okay? Is the motion of the particle confined to any regions on the x-axis? And if so, what are they? All right. And are there any equilibrium points? And if so, where are they? And are they stable or unstable? Okay. All right. So the first thing you want to notice that if this is your total energy line, right, all of this part up here is irrelevant, right? Because it can't ever get to any of those functions because it doesn't have that much total energy. Okay. All right, so between here and here, the ball could roll or whatever, right? And between here and here. Okay, so only in those valleys. It can't get higher than that total energy amount. Okay, all right. Let's see. All right, so if I want to do that, if I just need to find those x values, right? If I know that this is my function. Okay, there's a couple different ways you can do it, right? I know that this is going to be 0.25, and I need to find out which x values that happens at, okay? You could just use your graphing calculator or Desmos, right, to find those parts. Desmos was really super easy, okay? Or if you really want to, you know, do it all out all the way, right, you can just use your good old math skills. Okay, and you can factor this right into x squared, and then you can solve for those x values, okay? Right, or you can go onto Desmos and you can draw a line across and then see what the values are, or whatever, okay? So the first region was about negative 0.92 meters to negative 0.38 meters, and then on the other side, it was about 0.38 to plus 0.92, okay? All right, so that's just how you would find that, okay? All right, are there any equilibrium points? And if so, where are they? And are they stable or unstable? Okay, so everywhere the slope is 0, all right, we're going to be looking for equilibrium points, okay? So that would be here and here, okay? And I guess this would be here of the function, right? It can't get there in this example where the energy is only negative 0.25, but in theory it could, okay? All right, so at point negative q and positive q, okay, those are stable because they're in a valley. Okay, and then at 0, right, that would be unstable because that's like at the top of the hill, so any force would push it down. Okay.